This is the first time that I can recollect, at least, that these 5 panelists or these 5 companies have been on the same panel together, which is, I assume that to be true. So this is actually a monumental moment. And to put it in perspective, imagine if we went back a little over 30 years ago to the late 70s, early 80s, probably before all these guys were born. Imagine a panel composed of Bill Gates, Paul Allen, Steve Jobs, Steve Wozniak, and they're discussing the fledgling beginnings of the computer industry. I think you're witnessing a similar moment. They may or may not agree, but the industry that they represent, the industry that they're the founders and leaders of, is poised to essentially transform and fundamentally disrupt a lot of business verticals, much like the computer industry started to do about 30 years ago. And we're going to have a little bit of audience participation later on in the event tonight. And so during that session, I'll let you try to decide who the modern incarnation of Gates, Woz, and Jobs are on this panel. And so you can feel free to share your opinions later in the event. So what are we talking about today? Earth observation. Now, there's various terms of this industry sector. Earth observation, satellite imagery, satellite-based imagery, Earth imagery. For the purposes of tonight's discussion, these are all synonymous terms. Essentially, it is gathering intelligence and data about the Earth from space. And that's our focus for this evening. So most of you know that the space industry has been undergoing quite a bit of change. We're kind of in the middle, if not the latter half of the middle, of an inflection point in the space industry. Space is no longer being defined by companies like Boeing or Lockheed or even NASA for that matter. It's being defined by new companies coming up with radical new business plans that essentially are taking these business plans to derive value and offer value to various industries around the world. And the one sector in the space industry that I can point to without any hesitation as the primary lead that's fueling this inflection is Earth observation. There's no other sector that I can point to right now that I can tell you wholeheartedly is actually fueling this change. And so these 5 panelists, their representative companies, are actually fueling the inflection change within the space industry. And so tonight is a monumental moment that we have all of them together. So with that introduction, I'm going to flip through a little bit of an overview of what Earth observation is about, and then we're going to continue with our panel for the rest of the night. So there is quite a bit of history in Earth observation. In fact, the first image that was taken of the Earth from space was in 1947, and this is it. Pretty pixelated, pretty grainy, but it was taken in 1947 from a V-2 rocket that was captured during the war. It was launched out of New Mexico, and you can kind of make out the Gulf of California in the bottom left corner, and if you look all the way towards the horizon, that's actually California. So this is the first image ever taken of the Earth from space. We have come a long way since this picture. This is a picture from 1967 from one of NASA's satellites. This is actually, depending on who you ask, is one of, or if not the, most viewed image in the world. It's called the Blue Marble. It's the first time, 1972, taken during the Apollo 17 mission, first time that the actual Earth, the entire Earth, was photographed in one view. Now, there's many applications for Earth observation data. We're going to go through a few of those tonight. One is to monitor weather. This image is of Hurricane Anna that went by Hawaii. This image was from a couple days ago. This is an image of a volcano in Hawaii, and it was being used to kind of monitor how the coastline is changing in the bottom left corner. Agriculture. So one of the primary applications of Earth observation data is in this industry. It's helping to fuel the whole sector of precision agriculture. In fact, just the Earth observation data portion is well over $100 million today in this industry alone and growing exponentially. Now, imagery or optical sensors are not the only type of sensors that are placed on satellites. You can gather data from other means as well. This image is basically a mosaic of infrared images taken from various satellites. And it basically uses infrared as well as quite a few algorithms to filter out the noise, the light noise. And it's one of the few images of the entire continental US taken entirely at night. This is an interesting picture, now that I assume all of us here are Californians. It depicts the growing rate of drought in California. So it's a colorized image. And what's interesting is not only the image, save water of course, but it's the fact that it was taken, this data was pulled from a satellite that was monitoring gravity. Pretty interesting thing. So there's a couple satellites that NASA developed that are flying in tandem that are measuring the gravitational differences across various land formations. Water tables, or underground water, obviously increases the gravitational pull in that localized region. And so by using gravitational differences, they can actually map how much water or how much less water is now in California. Another application or sensor is actually, there's a whole field of chemical sensors. Now, this is a map of Southern California, the LA basin, showing carbon dioxide concentrations. And these are all pinpoint readings taken from a satellite that had a carbon dioxide detector. So various chemicals can be detected as well. This is just a cool picture I included. It's from the International Space Station. No major points around it, but I like the aurora along the horizon there. There we are, the Bay Area right in the middle. Now, this is a picture courtesy of Digital Globe. It's one of a recently taken picture from a couple months ago from their recently launched satellite, Worldview 3. And it's a picture of the Madrid airport. And so there's countless applications when it comes to looking at transportation infrastructure as well. We'll get into that in a little bit. This image is courtesy of Skybox Imaging from their first satellite launch, SkySat-1. And this is of a gold mine in Turkey. The interesting part, though, this is not actually a truly optical image. It's taken with infrared. And so with that, let's set the stage a little bit before our panel. So I always like to kind of introduce a few themes that I think the panel is going to gravitate towards as we proceed through the evening. And these are those themes. So theme number one is that we're kind of in the right time of market or technology convergence. So the time is now for this industry, and that's why you see these companies and hopefully a few more starting up as well. We're going to talk about what those trends are. Point number two is, or theme number two, is that we are going to talk about satellites and space and orbital mechanics a lot tonight. But this sector, this industry, is not all about space. In fact, that actually reminds me, throughout the event tonight, we're going to be saying a few controversial things just to kind of spark discussion and make it a little bit more exciting. So let me start off that line of thought with the first controversial point. I would argue that this industry doesn't have anything to do with space. And we'll hopefully discuss that, maybe with some vigorous discussion with the panel a little later. Point number three is that the applications that this data the industry develops or the data itself is very applicable across a wide variety of verticals. Pretty much everywhere and anywhere it can be useful across business areas and industries that you never would have imagined. We're going to hint upon a few of those tonight as well. And the last theme, theme number four, is that it's basically, we're just starting. This industry sector is just starting out, and it hasn't really even started to realize its full potential yet. It's essentially going to spark a wave of disruptive innovation across various industries. And that disruptive innovation is essentially, we're only limited by our imagination. We're going to do a little brainstorming on where we think we'll be 10 years from now as well. So let's, with that, let me introduce a quick business school-esque slide that kind of gives you the value chain of the Earth observation industry on one slide. It's grotesquely simple, so sorry if I offend anyone on the panel here. But let's start all the way on the left. Of course, you have to have satellites or stuff in space. Now, these satellites, mostly speaking, are in low Earth orbit, a few hundred miles up. They're orbiting about 17,000 miles an hour. They whip around every orbit about 90 minutes. That's enough about orbital mechanics for now. And then sensors. So the satellites themselves are platforms. On those platforms, there are sensors which eventually gather the data. So there's optical sensors, infrared sensors, eventually there'll be high-class UV sensors, chemical detectors, gravitational detectors, and the list goes on and on and on. And radio frequency sensors as well. So we'll be talking about a few of those classes today, because the panel kind of represents a few flavors of that. Depending on the sensors that you have, you gather a whole lot of data. It eventually, the middle box there, ends up as raw data. That raw data can be sold to customers, to various customers, but it also can be enhanced. So think of raw data kind of as a little bit out of focus, unrefined digital picture from your old digital camera, a little out of scale, but still has value to it. That raw image, or that raw data, can then undergo magic, which is that second to last box there. It's the software algorithms, the analytics, the intelligence that can be pulled out of that raw data that businesses truly value, that'll help them in their everyday or day-to-day tasks. So we're going to talk about that, what I call the kicker, the magic box, a little bit as well tonight. And the last one, of course, is why we're all here, why this industry is here, is that there are customers for this. People are going to pay money for it, and they already are. So we're going to talk about who those customers are and what the applications are that those customers are trying to seek. So I did mention controversial point number one. Let me go ahead and double down. I'll do one more right now. Things get a whole lot more interesting as we move from left to right on this slide. Value is generated. Actual intelligence or knowledge is sold to customers, not just a satellite image. You're selling to customers the actual context and information on what they need to enhance their business. You're not giving them a satellite image or raw Earth observation data. And so this is the controversial point number two, kind of feeds off my first point, is as you go from left to right on this slide, you'll notice that we're getting further away from things relevant to space. So with that, theme number one. So what are the trends that are helping to drive this industry forward? One is Moore's Law. So Moore's Law is not void in the space industry by any means. So Moore's Law is very applicable. So satellites themselves are getting smaller. They're getting easier to build, faster to build. They're getting cheaper. And that has a whole line or slew of consequences. Positive consequences, of course. So if you have smaller, cheaper, faster to build satellites, that also leads to less mass, which leads to lower launch costs, which has ripple effects all throughout your cost domain. And so going small doesn't come without its potential issues. And so resolution is one area that may be affected. And other capabilities of satellite are things that may be affected as well. So we're going to discuss that. So this slide kind of shows the differences, the massive differences between the sizes of various satellites. On the left side, we have a digital globe satellite, about 2,800 kilograms. All the way on the right is a 5-kilogram Planet Lab satellite. So pretty big difference. So we're going to talk about what does that mean? What exactly can you do with a big bird versus a small bird? What applications do each of those drive? So let's go back to my earlier point that this really isn't about space. Why do I say that? Well, the true art of this business, or the true art of this industry, and the true kicker of this industry is that the raw data that's pulled from satellites, whether it's imagery or chemical data or you name it, imagine terabytes and terabytes of zeros and ones that have to be translated, and the intelligence has to be pulled out of it to make it readily applicable to any business in front of you, whether it's the oil and gas industry or whether it's the agricultural industry. And so what this slide is trying to depict is that the true magic of this industry is how one finds the kernels of intelligence within this mountain of data. And it's not only finding the intelligence, it's finding intelligence over here and then finding it over here as well, cross-correlating those intelligence streams, which will beget more intelligence. And so it's essentially a highly refined analytical play that'll try to find value in large sets of data. I'm sure you've heard all that before, right? It's a very common theme that's taking place today. So we're going to discuss this as well. And here are some terms that you may have heard relative to this industry or others, which we might discuss tonight. And so where does this all lead? So the value, the intelligence that is pulled out of satellite data is applicable to a lot of different industries. And I would argue it's applicable to pretty much every industry out there. And why is that? Well, I would argue that pretty much any company or any industry out there is a data and software company. Doesn't matter if you're in retail, if you're a hedge fund, if you're an oil and gas company, if you're an automotive company. It comes down to the intelligence you can derive out of data available to you and how you implement that in an automated fashion. It's data and software. And the reason why these applications or these industries are ready to soak up Earth observation data, because it'll help them run their businesses. It'll help them increase revenues, reduce costs, increase productivity, compete against their competitors. And so I'm not going to go through all these tonight right now, but maybe for now I'll give you a quick flavor. In the agricultural industry, Earth observation is being used quite extensively to do various things. Monitor soil moisture levels, monitor soil chemistry levels, monitor the encroachment of foreign crops onto your field. They're able to then use that intelligence to prescribe very, very tactical things that a farmer or grower or large organization can do. When do we water? How much do we water? How much do we fertilize? What do we plant and when do we plant it? And all of this intelligence leads to essentially a greater yield per acre, which is kind of the holy grail of agriculture. And so that transformation of a traditionally non-data-oriented industry is taking place today, partially being fueled by Earth observation data. And with that, I will go to this. Now, we're going to talk about this throughout the night tonight. It's, like I said before, this is kind of the early stages, the fledgling, early baby steps of this market area. And I think the potential is very, very, very big. So we're going to take a few minutes tonight to talk about and brainstorm where we think the industry might be 5, 10, 15 years from now. And I'll leave you with this little point, is that much like the internet or the computer industry has done in the past, the potential for this market sector to fundamentally disrupt certain business verticals, the potential is pretty high. And it's not only that potential, this actually represents the classic definition of essentially industry disruption, because it encompasses technology and new business processes as well. So we're going to talk about that tonight. So with that, what I'd like to do is I'm going to introduce Teresa Condor, and I'll have her say a few words as our featured startup. And after Teresa, we'll have a few minutes for the others to introduce themselves as well. So Teresa.
Hi, everyone. Thank you for coming out tonight. My name is Teresa, and I handle everything on the business and customer side for Spire. And if someone had told me about 3 years ago that I would be part of building a startup and a technology startup to boot, I would have thought they were crazy. Because full disclosure here, I'm nowhere close to being an engineer, and I'm a little bit ashamed to admit in front of this crowd, I actually don't care about space that much at all. What I am excited about is the potential for big ideas that apply on a global scale into industries that really touch just about everyone on the planet in some way. And I really believe that what we're doing at Spire executes on that kind of vision. And that's why a little over 2 years ago, I was willing to leave my job on Wall Street, leave New York City, and come out here to California and be part of starting Spire. I can still remember quite vividly sitting over in the Hacker Dojo in Mountain View, writing our first business plan. We ended up joining the hardware incubator Lemnos Labs in San Francisco. We raised a little bit of funding, launched our first 2 satellites with only 9 months' time from the time we started, built a customer base, and then as many of you probably know, we recently raised a $25 million Series A this past July, did a rebranding, and announced a name change to Spire. So with that very quick background about our company, I want to go ahead and start the presentation by talking about nanosatellites, because this is the type of technology that we use. And we really believe that nanosatellites are disrupting the way that people access data from low Earth orbit. And because you have a much lower price point and now multiple launch opportunities with these type of satellites, you end up with more, better, cheaper data and the ability to very quickly put up a large constellation that is taking advantage of technologies that are on an exponential growth curve. And so when you have lots of satellites and you have improving technology, that means you end up getting lots of data. And so what I put up here is just a little bit of how you can think about monetizing that data that you're getting down from satellites. And as Amaresh kind of mentioned, you can go anywhere from the raw data, which is very simple, down the chain to owning the full piece where you keep all the data for yourself, you build applications on top, and it's all proprietary. And I think deciding as a startup which combination of these approaches to take and in what kind of order and timeline are very big strategic questions that we continue to think about all the time. Something else that we continue to think about and look at is the space industry in general and how it's changing. And so here I talk about the traditional space industry or satellite industry in particular, which used to be very hardware focused, or as we say, building boxes, where you would essentially build a satellite, deliver it to probably a government client, and the type of people that you really needed were all of these engineers and physicists and really smart people that know how to get that done. But in the last couple of years, not least because of all of these type of companies up here, we're seeing this change, and the model is now turning into data as a service. And one of the things that Silicon Valley has done very well is take complex, complicated technology and kind of wrap it up and make it look very pretty and simple, and then give it to the customer or to a company that they can use very easily. And I think the satellite and the space industry have not been very good at doing that traditionally, and that's just now starting to change. And so I'm out talking to customers on a regular basis, and most of them could care less that we build satellites. The type of questions that they ask are, what type of data can you provide? What quality is it? How simply can you get it to me? And then sometimes, can you tell me what I should actually do with it in the first place? And because of that, the type of people that are now coming into the space industry is changing a little bit. It's no longer just engineers and people that are kind of old space. It's a lot of people that actually have a similar background to me that know how to go out and talk to customers on their level and come from industry and can actually understand how these kind of companies want to apply this data. And so we really think that paying attention to the markets that you're going into in the satellite space is incredibly important. And that's something at Spire that we have focused very early on and have people with my kind of background from day one being part of the company. And that's actually still, I think, a little bit unique within the space sector, but is starting to change. So now I want to talk about the markets that we are in at Spire. And we decided very early on that we are not going to be a satellite imaging company, and I think people still sometimes think that we are. And we decided that primarily because there's plenty of companies sitting right here that are doing satellite imaging very well, and we didn't need to get into that market. What we do instead is RF sensor-based technologies that listen to the other 3/4 of the planet that is covered by oceans and remote areas. And basically areas where you really need a large constellation of nanosatellites that can get high revisit times and listen on a regular basis, where no other type of technology, whether it's drones or airplanes or car drive-bys, can really provide the type of data that you need. And so I'm going to jump back to that slide again in a second and talk about specifically the type of data that we collect, which is in the remote asset tracking market and specifically ship tracking. And so we're building up the capability to be able to tell where every ship on the planet is on a global basis in pretty much real time. So talking about multiple updates per hour. And this is something that you really haven't been able to do before. And it's not just talking about what is the GPS location of a ship, but it's a whole bunch of other information that you can then take and do analysis on and then apply to a whole bunch of different industries. So I'm going to go back to this slide now, and I have a whole list of industries up there that all use this type of ship tracking data, but apply it in very different ways. And each one of these industries are tens of billions of dollars in market size. And they're not necessarily fancy, but they're very important industries that touch a whole bunch of people. And so here I want to go and talk about how we do hardware development, but again in the context of what that means for us in looking at the market. So we have the ability to go and look at new sensor technologies that come out, test them, fly them on the satellite, put them in space, and then very quickly commercialize them. So while we're very focused on our initial markets and need to get revenue in the door and to scale, technology is always changing, what customers want is always changing, and the market is always changing. And so we see the need to be continually also looking into the future at what new type of data customers are going to want. And so I can go out and talk to a customer and find a new type of data they want that fits into this RF-based technologies, and we can go and be changing and looking into the future quite quickly. And so I want to leave you with this kind of picture of where we see this potentially going in the future. And that means that we can move from ship tracking to things like plane tracking and container tracking and truck or train tracking. And going down on a near real-time basis to understand and see the entire global transportation supply chain. And this is something that you cannot do right now in a cost-effective or a very efficient way. And we really think that things are moving in this direction when you talk about remote asset tracking, and not necessarily that it's going to be happening in 10 years, but really that it's going to be happening in something like 3 years. And I'm going to wrap up here, and I just want to do a little plug for Spire and our company. One of the other things that I think makes us a little bit different from some other companies is that very early on, we have been quite global. And so that means in terms of our location, in terms of the type of people that we hire, and the type of customers that we have. So we are based in San Francisco, and we also have an office in Singapore. We'll be opening one in Europe quite soon. We are actively recruiting, especially engineers, in all of those locations. And I think we have, a pretty unique internal culture and quite an interesting product and business model. And so I would just ask everyone to please check us out, continue to follow us and track our progress, and reach out if you want to. And so thank you, and with that, I will pass it back to Amaresh.
Great. Thank you, Teresa. Thanks. I'm going to quickly introduce the other panelists, and I would ask them to maybe take 30 seconds to a minute to maybe 2 minutes to talk about themselves and their company. So with that, on my immediate left is Pavel Machalek at Space No. Go ahead.
Hi. First of all, I'd like to thank VLab for the introduction. So at Space No, we're probably the only, well, definitely the only company here on the panel that don't have their own satellites. We're the software analytics layer. Space No, we deliver insights from all the different kinds of types of satellite imagery. So essentially, if you want to reduce it to a tagline, we go from the pixels to the insights, or from the pixels to the money, right? Another way to look at it. So we're the last piece of the value chain that Amaresh was showing earlier. We're a small San Francisco-based VC-funded company, 5 people and a couple of part-time. And we do large-scale. Our first product was a large-scale industrial monitoring program where we monitor and predict industrial capacity in entire countries. And we're developing other products. And we're very happy to share this panel and work with our industrial partners. And so, thank you.
Thank you. Robbie Shingler with Planet Labs.
Sure, thank you. Thanks for having us. This is an excellent panel. I really look forward to the discussion. I think you are right. This is the first time that we've all actually been up on a panel. So this will be really a lot of fun. So I'm with Planet Labs. We are based in San Francisco as well. I guess we're 3 of us based up in San Francisco. We've been around for about 3 years. We've launched 71 satellites into space, all of those over the last year and a half. And we have another 26 satellites that are going up next week. So we operate the world's largest constellation of imaging satellites. Those satellites represent about 6 different generations of our technology. And we aim to image the whole Earth every day. So this is via a very small form factor. You saw that one slide, which had a couple of numbers in there that actually weren't entirely accurate with respect to cost. I think DG satellites was 130 billion each or something.
Talk about it.
So some numbers are off, and enough said. So I look forward to the discussion. And again, we do operate spacecraft, but we see the data that we generate as really the fuel for our product, which is a platform for people to get access to information about the changing planet.
Great, thank you, Robbie. Next we have Dr. Shay Harnoy from Digital Globe.
Hi, thanks for coming out, everyone. So I'm from Digital Globe. We operate a constellation of 6 satellites, and it's on the left side of the spectrum, right? The big ones. We collect about 4 million square kilometers of imagery every day, right? So do you know what Putin's backyard looks like? Because I do, right? But that's just the problem, right? 4 million square kilometers. How do we convert that to information, to insight? So I lead our geospatial big data initiative, which is trying to take all these pixels, make them more accessible for analysis, to convert them to information, to make them into structured data such that we can query them, we can correlate them with other data sources. So my background, I came from an acquisition Digital Globe made last year of a company called Tomnod. It was a startup down in San Diego, and now we're trying to exploit every pixel that we collect from space.
Thank you. And then we also have Julian Mann from Skybox Imaging.
Thanks, Amresh. Really great to be here with you all tonight. I'm Julian Mann. I'm one of the co-founders of Skybox Imaging. We started back in 2009, and we have launched to date 2 sub-meter imaging and video satellites. Back in August, we became part of Google, where we continue to focus on building out our constellation of high-resolution imaging and video satellites, and ultimately transitioning this entire industry from one focused on the delivery of pixels to the delivery of knowledge, much in line with what Amresh said earlier.
Great, thank you. Thank you. So that's a great segue into our first topic that I think I'd like to introduce to the panel. And it's around the recent acquisitions or recent purchases in the industry, which were very telling. So one was what Julian mentioned earlier, is that Google actually purchased Skybox Imaging recently. And then also about 12 months ago is when Monsanto purchased a company called Climate Corporation. So Climate Corporation, for those who don't know, for very simplistic terms, is a data analysis company. They don't have any satellites. They are purely data analysis and algorithm specialists, and Monsanto bought them for close to $1 billion. So I wanted to kind of start off the panel on that end of our value chain, and maybe Pavel, you'd be a great guy to comment on that, because I heard you were involved in that deal. So why did Monsanto buy Climate Corporation?
Well, first of all, I can't speak for Monsanto, neither for Climate Corporation at this point, but I think the overriding message is that having all the data, having all the weather data, having all the agricultural data, having all the yield data on its own is all very nice, but what do you do with it, right? And the question is, can you tell the farmer what to do, where to do it to maximize his yield? And I believe, according to the press release, that was the main reason stated in the actual acquisition press release. It's the ability to unlock value, gain insight and unlock value out of unstructured and structured data, and make it useful and tell someone, look, this is how you can improve your life. Right now, do this way, and you'll achieve this specific outcome, and it will save you this much money. I mean, it's that specific. And so the previous company where I worked at Climate Corporation, they have that system, and it's terrific, and I'm very glad that they'll be a part of Monsanto, and they'll continue that mission.
Excellent, great. Yeah.
Comment on that. Well, was not associated at all with Climate Corporation, but it was really telling what you said in your original comments, which is every company is a data and information company. And why does a larger organization buy a smaller organization? They do it because it's a speed to market, or it saves them money, or it increased market share, or whatever it actually is. And that's exactly what's happening in agriculture. And I think really quite core to the reason why they saw an extremely talented team that is growing really quite well, that has a terrific technology and a terrific product, and a great leadership team that then they really backed, and now they've actually continued to acquire additional companies and are building out that information arm of Monsanto.
Excellent, great. So Julian, are there parallels to that deal and what Google has done or is doing now with Skybox Imaging?
So what I would say to that is, I think most people think of Google as a search company or maybe as an email company. I like to think of Google as the world's most sophisticated machine learning and computer vision company. And in the first phase of Skybox, our biggest challenge was, can we build the satellites and can they work? And we did that. We built the satellites, we launched the satellites, they worked really, really well. Now the challenge is, how do we transform all of these unstructured pixels, as Pavel just mentioned, into knowledge for as many industries as possible, as quickly as possible. And I couldn't think of any organization we would want to be a part of other than Google, who could make that a reality and allow us to scale the way we would like to.
I wanted to kind of come back to that erroneous slide that I had up there, so I do apologize for that. That unfortunately was produced by an angel investor, so I apologize for that. I'll go tackle the source. But speaking of that slide, and it's probably perfect for you, Shay, and Robbie sitting next to each other there, what are the differences between a massive digital globe satellite and something that's several orders of magnitude smaller, Robbie's satellites?
Sure. So without getting into too much physics, if you take your iPhone out, right, you look at the camera, it's really, really, really small, and you take your SLR, and the lens is much larger, right? And so most of the packaging and the size of the satellite is a giant freaking lens in space, right? And that allows us to see really small things on the Earth. So our newest satellite can see imagery, can see objects on the Earth that are about 30 centimeters in size, so about 12 inches. That's like if you mount it on top of the Hollywood sign, you'd see a beach ball on the Golden Gate Bridge, right? The curvature of the Earth and stuff like that. But I mean, ignore those, issues. It's quite remarkable and amazing. So I'd say that and the agility. So being able to swivel really quickly to take the shot when you need it, to aim between the clouds, et cetera. So that's kind of the vision that we have, is having these large area collecting machines, where the opportunity cost of any one small shot is actually quite high, because I could capture this farm, or I could capture half the state of Iowa. And so that's where there's a role for both the high temporal revisit as well as the high spectral and spatial resolution.
And Robbie, I wonder if you can comment on that and also help us define what temporal, spatial, and spectral resolutions are.
Yeah, so any sort of sensor or satellite that you put in space is really a solution that engineers optimize for across spatial resolution, so how fine grain you can actually see something, the image quality, and other types of phenomenology that you can measure if you wanted to look into different wavelengths. The system has three other attributes, which is coverage, so how much you can see, how frequently you can update that coverage, then the overall cost. And with Skybox and with DG and with ourselves and with Spire, these are things that our engineers think about in order to optimize for, because each one of those things is a trade-off. And we chose at Planet to innovate on the latter three things. Global coverage, updated very frequently, at lower cost, so that we can actually grow the market of users who get access to information.
And since you have so much coverage and eventually will have very frequent revisit time, are there any restrictions on what you can take pictures of and what you can't?
Sure.
And that's probably why don't you start with that, Robbie, and we'll kind of go around the table here.
Yeah, so all three of us, four of us, are U.S. companies, and in order to operate in space, we have to request the U.S. government for licenses. Being a commercial remote sensing system, we do that through the Department of Commerce, which is then coordinated on behalf of the entire government. And that goes through a pretty onerous validation process across the government, from DoD to Intel to also civil. Roughly speaking, there's one major thing that is restricted, which is 25 meters per pixel, or sorry, centimeters per pixel, is what you can sell on the commercial market, which was actually just recently relaxed right prior to Worldview 3 going up. Before it was a half meter per pixel. So it's mainly been around spatial resolution, but this happened about 20 years ago when the Commercial Remote Sensing Act came out, when there were when there were 0 commercial remote sensing systems out there, they created this act in order to stimulate commercial industry, in order to do more rote-related surveillance capability that the government can buy. So at that point in time, all the regulations were in place, thinking that there'd be singles of satellites and not necessarily major constellations of satellites. But right now, the main thing is spatial resolution. Then also you have to go through the FCC in order to irradiate over the United States. So if you have a ground station in the US, you have to gain access to spectrum and be good spectrum neighbors to other people that you're sharing spectrum with.
So I wanted to mention, I forgot to earlier, that the audience members can actually ask questions. And the way you do that is up there on the slide. You can text them, or I believe via Twitter as well. And once you do that, through miraculous magic, after they're vetted, they appear on my little iPad here. So we'll start asking these questions gradually over the next 10 to 15 minutes of the program. So please start asking. I wanted to kind of step back a bit, since a lot of the companies here are traditional startups that have started recently, have raised money, went through the entire business plan, raising money, the valley of death type scenario, and have emerged victorious so far. So I would say, I wanted to get back to how these companies were started. And I really liked Julian's story of how Skybox was started. So maybe Julian, you can comment on that and talk about, obviously, the tie to the place we're in now.
Yeah, absolutely. So we were actually started here. I guess not technically here. We weren't really started at the business school. We were over in the School of Engineering. And prior to Skybox, actually, I had co-founded another company with my professor that was focused on taking this really small, really low-cost satellite technology out of the university labs and trying to commercialize it. And we were focused on pursuing government grant money, so we raised a decent amount of money from a number of different government agencies. The second round of contracts came out, and suddenly it wasn't little us bidding, it was Boeing and Lockheed and SAIC. We realized that was just never going to be a recipe for success, because they could spend more on capture for that contract than we had spent in our existence as a company. And so we took a step back and said, well, what can we do that they can't? And I think that's actually going to be a thematic trend that we're going to need to return to throughout the course of the night, which is, as a startup, we have to be looking for unfair advantages, because we have so many disadvantages that we're up against. And the unfair advantage that we had is being at Stanford with access to Sand Hill Road. We said we can go raise money privately to pursue a real business and accelerate the development of this technology much more quickly than we could if we were pursuing government grant money. And so that was really the origin story behind Skybox. We iterated on the technology a little bit, and then really learned that we needed to focus on the product and the market, another key theme to come back to tonight. Came across imaging, came across sub-meter imaging, and the last 5 years of the history.
Great. And I think Digital Globe is the older company on the panel, although not that old, right?
Yeah.
So I was wondering if you can comment, Shay, on how it got started, and maybe comment on what that act was back in the early 90s that helped get the company started.
Yeah, so after the fall of the Iron Curtain, right, there was all of a sudden this interest, and the Remote Sensing Land Act, is that what it is?
Yeah.
Of 1992, I believe, right? Was created to encourage commercial companies to participate in space. And so my boss actually founded the company in 1992 in anticipation of that act coming out. And think about it. The only thing the world knew were these government programs that had these satellites behind closed doors where nobody could see the data. Nobody could see the data. And it was a huge innovation to bring this to light, right? To make it accessible to companies, to allow people to respond to humanitarian crises like never before, to be able to track agriculture, to be able to track financial results, right? And that was just like the infancy. The first 2 satellites blew up. Actually, the first one didn't make it to orbit. The second one didn't deploy a solar panel, or maybe it was the other way around. Talk about dilutive events, right? But through a series of learnings and iterations, the first satellite, QuickBird, it was QuickBird 2, which we just call QuickBird now, was launched and is actually still operational. And so it was actually quite a dramatic story of how do you even build a market for this, right? This doesn't even exist. Pictures from space? What? Right? But being able to iterate on that and finding use cases both in the government and the commercial sector, I really feel like we're there again now. But it's less about getting into space. We're over it, right? You don't even like space.
I don't.
I'm with you. I don't even like it either. It's dark and cold. But it's really about what do we get from it? How do we convert all those pixels into information? And I think you're going to hear that theme throughout.
Exactly. No, great answer. I like the fact that it's not about space. It's much more and different than that. So with that segue, Pavel, I'd like to have you comment on, it's not about space, so what is it about? What type of information can we extract? And I know Space No is kind of focusing on that, and transform that to applications that customers will find value in.
Well, that's an excellent question, and it's basically, the reason why we got created, and I imagine a reason why a lot of people are sitting here on the panel with me here, is that, for example, the kind of questions that we go after, I call our company the question and an answer company, right? There's questions and answers. For example, let's go specific. If you wanted to know, and I'll go, we saw the large collection of different industry verticals you can go after. I'll pick, for example, let's pick manufacturing, right? You have some country, and you have 10,000 factories in it, in 5,000 industrial locations. The question is, how much is being manufactured? What is being done? How is that changing? How much of it is there more being manufactured than yesterday? Is there more being manufactured than a month ago, a year ago, or 10 years ago? And that it wasn't possible, or it wasn't cheap and readily accessible to answer that question just probably 5 or 10 years ago. But now, because of all these amazing images that the companies are producing, all the available computing availability on the cloud, so whether the Amazon or Google cloud, and the economical cost of that data, it's possible to put all that together, make that computation, and actually come up with an answer. Yes, this country is producing less than what it was yesterday or a month ago. That's one example that I can speak for. And these examples can be found in pretty much every single vertical that you've mentioned.
Absolutely, and that's actually a great transition to Teresa. I wanted to talk about Spire. It's the only company on this panel that is actually using sensors for radio frequencies, for sensing radio frequency, non-optical sensing. And so can you comment on that specifically, on how that translates to a different set of applications that other companies on this panel are not necessarily best suited for because of that sensing mode?
Yeah, I think as you've seen, a lot of people are talking about the benefits of imaging when it comes to agriculture. And again, that's talking a lot about landmass, which is really only a small part of the planet. And what we do is related to the oceans and remote areas. And so a lot of the applications that we're looking at apply to the shipping industry or global commodities industry, but then also it can be Wall Street or international trade. So I come from the international trade background, and it's something like $18 trillion globally, and 90% of that is transported by ship. And I was coming from Citibank, and we would always look at how are these global trade flows moving, because we would want to know where we should be offering more credit and how we organize our business. And that type of information is actually really difficult to find unless you want to wait a year and a half for all the countries to report their figures. But if you're able to track every ship on the planet, and that really tells you quite a lot about economic activity and can give you insight very, very quickly. When it comes to illegal fishing, you can start doing kind of AI algorithms on top of it and be able to tell whether someone is actually fishing where they're not supposed to, or if they're fishing for a different type of species than they say that they are. Some other interesting examples in the shipping industry relate to route optimization and fuel efficiency. So a lot of shipping companies right now are worried about their CO2 emissions. They're worried about, are they getting someplace in the fastest way or in the most efficient way, or just in the way that saves them money on their fuel costs. And these are all things that the type of data that we collect makes sense for. But I think a lot of it is also the combination of data. And so the combination of the type of information that we're getting on the sensing side with imaging and how you can combine those things. And I think we're just starting to have people scratch the surface of thinking about how you can actually combine different data sets. And that's the kind of thing that Pavel is doing too.
Right, right. And do you, are the other companies on this panel, are they competitors to yours, or do you view them as partners or collaborators?
No, absolutely not.
Yeah.
Everyone thinks that they are.
Yeah.
But we don't do imaging, and in fact, I think it exactly makes sense that we would talk about how can our data combine with one of these other companies. One of the big applications that we keep hearing about is on the security and the search and rescue side, where a lot of people don't realize that the EEZ or the territorial waters of a country is usually larger than the size of that entire country. And that's actually true for the United States as well. So you have vast areas of ocean where all kinds of things are happening that no one can quite tell. And if ships are going by and turning off their beacon, like people hear about can happen, well, we can find out right away because we're tracking those beacons, but we need to come to another company and say, okay, here's coordinates where something happened, go take a picture, and we can do something about it. And that's an example of partnership and not really competition.
Great, great. So I'm going to start introducing audience questions now. So beware. They're not entirely, they're good, hard-hitting questions, to put it that way. So let's start with competitive technologies like UAVs and drones, things that can actually potentially hover above a site, or high-altitude UAVs like Titan Aerospace, which Google bought recently as well. Anyone want to start with that? Are there competitive technologies out there, and how does a company like one of yours address that?
So I'll jump on this one. And I'm going to address this in a little bit of a roundabout way, which is back to your original point. I actually don't like space companies. I very regularly am approached by people who say, oh, I've got a space company that you really need to see, or venture capitalists who've approached me and said, do we need space to be part of our investment thesis in our next fund? And what I tell them is that you're looking at it the wrong way. I'm interested in businesses. And back to that previous point, that comes down to what is your product and what is your market. And ultimately, doing things in space is really hard and really, really expensive. And your cost to iterate on your technology is in typically the tens, if not hundreds of millions of dollars. And so ultimately, if you have a good business model, the first step is to say, how can I possibly do this that doesn't involve space? And so if I can do that with a UAV or a balloon or a bunch of cell phone cameras, that is a far more efficient, far lower cost, and far easier to iterate approach. It just so happens that there are a lot of things you can't do with those systems. And so with that, what we're seeing with all of our companies up here is that the barrier to entry for taking that step into space is now for the first time at a point where if you have a really good business that requires operating in space, that doesn't prevent you from getting started. You actually can go off and do that. But if you can do it any other possible way, please do, because you'll have a lot more hair at the end of the process.
That's a great answer. So for the record, I'm a fan of space, but for this industry, it may not be the primary theme. It's actually one of the tertiary, if not lower down the rank themes. Robbie, do you want to comment on this?
I love space. I mean, So yes, every company is an information and a data company. So that really resonated with me in the beginning. But yeah, I worked at NASA all of my career. I was there for about 10 years. I built a lot of space sensors and systems, and they're people that are actually in aerospace, they love solving hard problems, right? Engineers love solving hard problems, but there's this thing with space that actually brings out more of the sparkle in people's eyes. And that passion, if you can actually harness that and wrap a business model around it, of course, I think is actually something that's really quite unique about this sector, because you get so many passionate people, and you can take on really big, audacious goals. That ends up being quite a large comparative advantage. So you're not trying to compete with, people that are doing a social media thing here or like a web app there. You're actually doing something that has a big, hard challenge and a good thing for humanity. So I wanted to state that I'm totally a space geek, and
You need those two.
and you need those two.
Actually, Robbie, can you comment on the topic of space debris?
Sure.
So if you're launching so many satellites up there, what happens when they're end of life? And
Yeah,
what do you do
absolutely.
with other debris?
So space debris is absolutely a very serious issue in the aerospace sector. And the majority of debris is actually upper stages, dead satellites from the last 4 to 5 decades that have gone up into space. And a lot of them happen to be in orbits that Earth observation companies like to be in. They're in a sun-synchronous orbit, or polar orbit, around 700 to 1,200 kilometers. And a lot of them are dead. And it is an issue. There are lots of research happening on this particular topic. And there are things that you can do in order to get around what's called the Kessler syndrome, in order to get around this cascade of this challenge. But it is actually a larger issue. Now, for us, we take that very seriously. And from the very beginnings of our company, when we designed the overall constellation of what we were doing, we wanted to fly low. We wanted to fly low because for a small aperture size, you can get a decent resolution. We wanted to fly low because for the amount of power that you get for your radio, you can get a lot of data down. And that goes with distance squared. So if you fly low, you get more data down. Then if you fly low, you're in the Earth's magnetic field, which is more stronger, so there's less radiation. 15% of the global launch market is going to service the International Space Station. There are all these reasons why you fly low. And lastly, is you fly beneath where the space debris is. So A, you don't get hit by it, which is a good thing, and B, you don't contribute to it, right? And so our ideal orbit is an orbit in which we would re-enter destructively in the atmosphere in about 3 to 5 years, so that we actually don't hang out and we're actually dead.
Great. Let's shift gears a bit to a purely customer-focused line of thought. Let's talk about customers specifically. And Shay, let's start with Digital Globe. And I know Digital Globe.
Shy, by the way.
Shy, sorry. Let's talk about Digital Globe's government customers and how does that differ to commercial customers?
Yeah, so at Digital Globe, we have about half of our business to the U.S. government, which is a really good customer of ours and keeps pushing us to innovate, right? They have larger and better demands for commercial satellites, and we aim to please. At the same, on the other end of the spectrum, we have a substantial commercial business, right? We just acquired a company, Spatial Energy, to double down the oil and gas sector. And what that means is you think about these investments that are going on around the world, right? That these oil and gas companies, the energy market in general, is dependent on. And they're investing billions of dollars in assets in really remote and sometimes nasty parts of the world. And being able to track those assets, identify environmental baselines, environmental monitoring, security monitoring, et cetera, is a constant theme that's resonating in that sector. Now, that is just one sector. We have many partners that are bringing space-derived information to their respective verticals. And so we have a substantial partner network that is targeting various verticals to bring some of these insights to light. But honestly, we're really at its infancy. Most of our customers are really smart about imagery. They're really smart. We call it pixel torturing, right? It's like they're really good at squeezing value out of pixels, but there aren't that many people of those people in the world. So how do we make it easier and more accessible for people to do that? And so that's, through partners and through our investments in the coming years.
So this is actually a good segue, an open question to the entire panel. That value chain we had up before, that kind of showed the various boxes, most of the companies on this panel are addressing a large portion of that value chain. Where do you see the industry playing out if we go out like 5 to 10 years? Are we going to have pure specialist plays like what Pavel is doing on the latter half of the value chain? And then pure space plays, those who focus on the satellites themselves? Are there going to be raw data vendors? Where do you see the ecosystem kind of evolving? Because a lot of the companies now are kind of doing most of the tasks involved in that value chain, if not all. So anyone, feel free to comment on that. And Pavel may be a great guy to start with, because you're taking that right half of the value chain and you're not worrying about the other part.
Well, I'm clearly biased, right? I think everything is going to end up as software, and software is going to eat all the satellites. But that's a very, very biased view. There's so many questions to be answered, and literally the whole globe, you have 7 billion people, and every day, every one of those 7 billion people, they do something, right? They wake up, they drive to work, they do something, then they drive home from work, and then they go to sleep, right? So 7 billion people doing that makes a lot of change in the world. Every single day, the world completely changes, right? And there's a lot of satellites to look for that change. There's going to be a lot of trillions of pixels, hundreds, maybe thousands of satellites within the next 5 or 10 years. And it will be a tremendous amount of change, and it will need to get analyzed, and will need to get interpreted and served to the customer, whether that's a consumer, enterprise, or government. And I think all of us will be very busy doing that, but I think will be more and more software.
Okay.
I would say that I think you need satellites up there, but it's still not easy putting satellites up. And so once you have a couple of companies that are doing it, it doesn't make sense for too many other people to come in and revisit all of that, which is still a decent amount of investment and effort. And really the true value add is when it comes to the software and the analytics and the applications around it. So I do think there are going to be more and more companies popping up like Pavel's that just take the type of data that our companies and some of the other large satellite companies produce and use it and build on top of it applications. And there's enough industries, we keep talking about this whole list of industries that use satellite data. There's enough for multiple people to be building products.
Robbie?
I think this trend will continue, right? Which is to really create actionable insight out of information that's collected from a variety of sensors, whether from space or from not from space. But on the space side of things, this is like the most exciting time in decades. Costs have decreased. This all came out of actually here at Stanford. Bob Twiggs was a professor in the Aeroastro department. In 1998, he had a design-build workshop that was called CanSat. And so he challenged his students to build a satellite inside of a soda can in a semester, right? And what that did was allow people to think differently around it being possible to build these spacecraft, and to think about it from a systems engineering perspective. Out of that came the CubeSat standard. And then a few years later, there was a whole bunch of CubeSats sitting in university clean rooms, and then we had to get into space somehow, and that's where P-pods came from, in order to then get secondary payloads access to space. So the things that are happening in space now really came out of here, and the things that have actually made it commercializable, a lot of that actually came out of the Valley. And so much of that is actually due to a lot of the hard work that Julian has done with his co-founders, and being the first VC-funded company in this space renaissance. And more than that, having a successful exit and actually having investors make money. So it's awesome. And so now things are happening in aerospace a lot more dynamically. There isn't an issue. There's a trade magazine called Space News There isn't an issue of space news where there isn't a new concept for a new mission. So if you think about the economy of what happens in the aerospace community, the mass majority of it is in downstream services for sure. But there still are going to be quite a bit of new sensors that can go up in space that can measure new things and open up new markets. And whether that's in RF or whether that's in weather, right? Weather right now is not in commercial domain at all. It's actually something that governments do. Positioning satellites are not in commercial domain. That's something that governments do. And there can be a lot more activities that are actually happening with decrease of barriers of entry into space, which is not just the cost of launch, but also the ability to build a very meaningful payload that you can get into space quickly. And then also what's happening outside of commerce, there's quite a bit of activity that's happening in personal spaceflight as well. So I think that it's the best time to think about new businesses in aerospace, but please do underscore that first word, which is a business. You do want to make sure that there is a market entry for it, that there is a market need for it, but the capital is available, technologies are there, and regulators are actually still scratching their head a little bit about what's happening, but they're doing a great job. I mean, they're actually doing their job really quite well, and they want to encourage this new economy to flourish.
And kind of taking that to the next extension, I wanted to draw a quick distinction between kind of aerospace engineers, satellite specialists, and then the other half of the equation, the software engineers, the data scientists, the algorithm specialists. So I wanted to throw this question to both Julian and Shai. Can you comment on that? Like, how is your company transitioning between aerospace scientists or aerospace engineers to the software data analytics, data scientists?
Well, I have a really easy answer to that one, which is we went from being a satellite company to now being part of the biggest software company in the world. So it's pretty easy to see that transition. But back to the previous point, actually, I want to ask a question to the audience, which is how many people today would want to start a company as a computer manufacturer? Question number 2, how many of the biggest companies in tech manufacture their own computers? The answer is all of them. And so when you think about how is this industry going to evolve over time, the biggest players in the industry are going to own their own manufacturing because manufacturing is entirely commoditized. Because of the revolutions in modern manufacturing in general, we're going to skip over sort of that interim period where there was still a lot of opportunity to be made as a generic infrastructure manufacturer. I think we will see some companies emerge that are just operating on the data because the data really is where all of the value can be extracted. But back to that unique advantage point, for several years to come, I think it's going to be very, very difficult, and this is nothing against Pavel, I wish them absolutely the best. But if you don't own your own data, you have no competitive advantage. And ultimately, although all of the companies up here and the other companies not present in remote sensing have made comments about making data open and accessible and interoperable, to date they've all been platitudes. So I think we need a lot of things to change before there's really going to be able to be significant and sustained opportunities for lots of value creation to be made solely as a sort of a data analysis play and not without the infrastructure as well.
But just to add to that and kind of ask a question to the panel, Google is actually one of the best examples of how data is democratized and actually quite free to the average user. So do you envision a point where satellite Earth observation data is ubiquitous and free, much like the information available on Google or via Google? And the true specialization and value is taking that free raw data and doing what Pavel does.
Like the extreme of commoditization, right?
Exactly.
It's having it totally for free. Yeah. So if you look at the full chain, right? I think there's innovation to be had in the space, in sensors, across the entire chain. If all these new startups do is take Digital Globe's market share, we will have failed as an industry. Nobody would have funded Julian to take Digital Globe's market share, Digital Globe or GOI's or everybody combines market share, right? that wouldn't have happened. It's all about new opportunity and seeing the world in new ways. And that requires, while we're pretty sophisticated, right? We've been around the industry has been around for a while. We're pretty smart about a lot of things. We're still pretty dumb about a lot of these end use applications, right? And it takes a lot of expertise in the market. So Robbie brings up the market, right? Understanding everything there is about the insurance market, right? And how they like to purchase their data. What sort of accuracy do they need? What sort of revisits do they need? What sort of insights do they need before you go and figure out what tools you need to bring it to market? And so maybe it is a platitude, but I encourage you to go. There is an ecosystem being built around here, and now is the time.
And so that actually brings up a great point. When some of the companies here actually raised money, what was the pitch to investors? So maybe I'll ask that to Teresa. When Spire raised their recent round, what is a 30-second elevator pitch to investors? What do they resonate with before they write you that check?
I mean, we're a satellite-powered data company. So it really is all about the data and the analysis that you can do on top. And it really is about us understanding the markets that we're going into and being very different from some of the existing players. Because everyone is talking about imaging and gets it, and no one is talking about these other type of sensor technologies and markets where they're not very fancy or very sexy. If you're talking about shipping and you're talking about maritime insurance, and they're very conservative, old school markets that no one in Silicon Valley really thinks of, but they're all huge markets. And so I think we are just doing a different type of data, really understanding unique markets, and this whole proposition around nanosatellites and the type of data that you can get down and the frequency with which you can get it, that leads to the applications that you can apply it to. And that's pretty unique.
Mm-hmm. And taking that one step further, what is the killer application if you were to pick one? Which I know is a tough job to do, but let's go down the line here. Pick one application and describe it in a way where the audience will potentially resonate with that application.
Wow.
So probably not, let's not talk about, I don't know, a specific industrial insurance type app.
Wow, that's a big question. I mean, for example, if you wake up in the morning and your smartphone gives you a push notification, it's like, hey, right around you, we have this new high-resolution image from Digital Globe, Skybox, Planet Labs, and this is what's changed, and this is the very specific insight that's happened today morning, and here's an actual image from today morning, and the house, 10 houses down, either has a new roof or has a solar panel on it or burned down last night, whatever, right? And you're like, wow, and this just happened, and here's an image from space. Like I think that future is coming, and it's going to be very fast. Like the data is going to be very fast, and the insight is going to be very specific, and it'll be very specific to you, to your location, and to your personal preferences. I think that will be cool when that happens.
So I'm not going to give you a killer application because, I mean, number one, we talked about so many different industries, and so it really is going to depend on the industry. But I also want to bring up the example that actually our CEO likes to talk about a lot when it came to people saying, what was the killer application for the PC? And I don't really remember this time period, but what he always says is that the killer application back in the 80s or something was supposed to be you can keep track of your recipes for housewives on your computer. And that was the killer app. And of course, nobody uses it for something like that. And we have a whole bunch of different applications that have come up that no one could have possibly thought of by themselves. And so I don't think it makes sense to talk about, let me predict the killer application, because it's really going to come out of a bunch of companies and a bunch of people like Pavel and data scientists and people who know an industry really well, creating things, and they're gonna come up with something that no one by themselves can imagine or predict.
That's a very good point. I mean, when the internet first started out in the mid-90s and kind of grew, no one would have projected that 15 years down the road, there'd be 1.x billion people on Facebook, and that'd be a killer application. So you're absolutely right. I think setting the foundation such that later on applications can flourish is kind of the model that I think you just spoke of. Do others agree with that approach, and is that the way the industry is going to play out? The applications will come if you build a foundation?
Yeah, I mean, I was going to say, from my perspective, the killer app is to build the ultimate constantly updating model of activity across the planet at a human scale, and exposing that information in a way where hundreds of thousands of developers can build the individual atom-size applications that are relevant to them. So I don't think there is just one easy bite-size application. It's when this information becomes an underlying piece of sort of our living infrastructure that it becomes a killer application.
How do we talk to critics that say this may sound like Big Brother from space, and there may be some privacy concerns at play? What's the response for that? Is there any?
Well, so from the Skybox perspective, at our resolution, we're inherently anonymized. We can see that there's a car, but we can't tell you what car it is. And so we're much better positioned to be monitoring, overall trends in activity and characterizing behaviors based upon that, but not identifying, anything that's individually identifiable.
So from Digital Globe's perspective, we also cannot see beyond anonymous shapes of humans. But if you think about what's in your phone and the amount of information that you contribute in your phone, I believe that as far as remaining truly anonymous, I think being a shadow in an image somewhere in downtown block is much less concerning than the amount of information we voluntarily contribute. And I think that the advantages of having this technology available for the world to access vastly outweighs it. So let me give you an example, something I'm really passionate about. So my company, TomNod, that got acquired by Digital Globe, did crowdsourcing of satellite imagery. What it means is, instead of having one analyst looking at a picture, you have lots of people. All of you could contribute. And in fact, this became quite instrumental in the search for the missing Malaysian aircraft, MH370, right? We had 8 million people around the globe looking at the most boring imagery ever collected of the middle of the Indian Ocean, searching for clues that could lead to the discovery. Now, although MH370, we didn't find it, right? We believe it's submerged. We actually found a missing boat off the coast of Brazil last week during another search and rescue campaign. Now, unfortunately, the life raft was recovered without the presence of the people. But that's kind of the things that we're trying to enable, right? This goes beyond just industries. It's understanding, populations as a whole and helping humanity. So I don't mean to be cliche, but it's true, right? We can see into Ebola. We can respond to it. We are responding to it, right? And these are things that mankind, we need accessible.
I think this is something that we as an industry should be on top of. Because it is going to be a concern. There are glorified movies and all of the stuff that's in popular press, and we do have the enhance button. And we could describe the fact that we can't make out what car it is or what person it is, or our spatial resolution where you see a tree, and so if you're bigger than a tree, then maybe we'll be able to see that there's a person there. But that is actually, the conversation needs to be around the benefit, right? It is a capability that allows us great insight into what's happening, so that we can then respond to things and we can mitigate loss of life, or we can actually make things more efficient. The amount of actionable information that comes from satellite data is really tremendous, especially in natural disasters and in other types of applications. So not only is it good for commerce, but it has a huge amount of societal benefit. So we as a community do need to kind of communicate it and actually own it, that it's an issue, right? It's an issue just like any of our cell phones, and this is part of being a responsible actor when you are collecting information. I mean, this is a salient thing, especially in particular cultures are a lot more concerned about that than others.
So we're approaching the end of our panel, and I wanted to kind of pose a question to each of the panelists and take that question and kind of morph it, if you can, into your concluding remarks. So where do you see your company in 10 years? Anyone can start. We don't have to go down the line.
Go the other way.
Oh, great.
I really do believe that remote sensing information is currently just at the very, very early stages of where it can ultimately be. And I think if you look at the types of decision-making cycles in which it's truly and deeply integrated today, we're really only talking about very, very limited, mostly defense and intelligence type applications. And when you look at the big technologies that have changed the way humanity functions, be it telecommunications, the internet, GPS, those all started in that same way. It was limited to a few heads of state, and ultimately, as it expanded and became available to everybody, new applications that changed the way in which humanity functions were enabled. And I think that is exactly what we're going to see with remote sensing. And I think now, as part of Google, we are going to continue over the next 10 years to be an absolutely fundamental piece of that infrastructure that will end up permeating applications and industries that we can't even imagine today.
I would say that what I'm most excited about over the next 10 years isn't so much looking at the same spot on the Earth over and over and over and over again, but it's looking at many spots on the Earth and understanding correlations between these places and how they act together. This is kind of the big data approach, which I think is the theme of tonight. It's not looking at one place, but it's looking at all the places and understanding what's going on at scale. That hasn't been done. That surface has just been scratched barely, and we have a lot of opportunity ahead of us. So everything that Julian said, plus more. No, I mean, I want to leverage what you said.
I see that maybe this gets also, I didn't really respond to the killer app question, but I agree also with Julian with respect to it being a platform, right? And what can actually come out of that, we don't really quite know yet. But the thing that I'm most excited about is being able to allow for everybody to understand the state of the world as it is now, as it is today, and to give humans context to the micro level decision that they're making in a spatial context. I think that's something that in 5-10 years from now is going to become rote. The fact that we were making all of these decisions around supply chain management or cultivating here or selling there without actually understanding the state of the world really the way that it is right now. So I think that is going to happen over the next 10 years, at least from a planet perspective. We hope to be part of that. We believe that, that this is what we intend to build, is imaging the whole Earth every day and democratizing its access, and that's our focus, and building a vertically integrated organization along the way and being space geeks. We may be able to then do a mission number 2 and a mission number 3, which would also use that internal value chain that we've created.
I mean, certainly I think we plan to be building out a large constellation because we do use the nanosatellites that makes that possible. We do see ourselves as a platform as well, where, as I mentioned, you can rapidly identify new sensors and update them on your infrastructure and go into new markets. And so I think having very high revisit time and really almost real-time visibility across a whole bunch of different markets is something that is going to happen, similar to the last slide that I put up there. And I think we keep having miniaturization of sensors that right now cannot fit onto nanosatellites, but will be soon. And we're going to continue looking at all of those types of technologies. And I think it's unclear 10 years from now exactly which sensors we're going to be using. But I think we're going to continue to collect data, put it into a database that you can do analytics on top of, and that is going to really give insight that help businesses make their businesses better and continue to drive the global economy.
Wow. What to add? I think these are all amazing points, and really making imagery available, relevant, local, and just interesting to people is one of our goals as well. I guess in 10 years it would be amazing if of the 10 billion people, or 15, or God knows how many people will be there on the planet, then really all of them, or like 80, 90%, could have access to a relevant, timely, specific data product derived from a satellite image that could be delivered on their cell phone, their smartphone. And that was an hour old, 1 hour old, right? And it just happened today. And this is highly specific to me, and it's highly relevant, and it's essentially as prevalent as Facebook and as addictive as Tinder, right? I want to make that thing happen, right? That satellite imagery can go there, and with the help of our industry partners, we very much look forward to make that happen.
Excellent, thank you. Well, please join me in thanking the panelists for a wonderful panel.